This is the California CBEST exam. This is the practice exam for the mathematics section, and it's problem number 22. At the beginning of a class period, half of the students in a class go to the library. Later in the period, half of the remaining students go to the computer lab. If there are 8 students remaining in class, how many students were originally in the class? We're going to look at 2 different methods to solve this problem. The first method I'm going to just call reverse logical arguments or reverse logical procedure. That is, we're going to start from the remaining students. That is, we have 8 remaining students in the class. And if there are 8 remaining students in the class, and that represents half of the class that had left to go to the computer lab, there must have been 8 students that went to go to the computer lab. So we have 8 plus 8, which of course is 16. Now, of those 16, that represents half of the class, and half of that class went to the library earlier. So we have 16 plus 16, and that gives us 32. There must have been 32 students in the class. Now, there's another solution, and it's an algebraic solution. Going to take a little longer, and it's going to take a few more steps, but in this case I'm going to use it just because you ought to start being able to think in these terms. So let me go ahead and first of all let's represent x as being the total number of students in the class. Okay, we're no longer working backwards, we're now working from the beginning of the class. So x is equal to the total number of students in the class. If x represents the total of the class, 1/2 of the total went to the library, which means 1/2 of the class remained. So we have 1/2 x. And then later in the period, half of those students, so 1/2 of the 1/2 of x. So this represents the number of students that went to the computer lab, and there are 8 students remaining. So all of that is going to equal x. Alright, now let's go ahead and solve this problem. We'll go ahead and rewrite this as x over 2 plus, here we have 1 times 1. Well, actually this is going to become an x over 2 as well, won't it? Let's just go ahead and erase that. There we go. So this is now x over 4. 2 times 2 is 4, plus 8 is equal to x. Alright, well, when we have fractions, we have to get the denominators the same. So the only way to get the denominator the same here is I'm going to multiply this by 2 over 2, okay, which is the same thing as 1, so I'm not changing the value. I'm just going to get the denominator of 4. Alright, so we'll rewrite this then as 2x over 4 plus x over 4. Let's get rid of that 8 on this side here, equals x minus 8. Eventually we're going to want to isolate this x over here as well. That's why we're moving this 8 over here right now. Alright, 2x over 4 plus x over 4 is equal to 3x over 4. Okay, and then we're going to subtract the x, equals negative 8. Let's combine these terms, except the only way I can combine these terms is I have to multiply this x by 4 over 4, right? So let me just go ahead and put 4 over 4. Again, we're multiplying this x by 4 over 4, which is a 1, so we're not changing the value, but we're getting the denominators the same. So we have 3x minus 4x is negative x over 4 is equal to negative 8. Now the only way to get the x by itself is to get rid of this 4 in the denominator, so we're going to multiply this by 4, and then anything I do to this side, because I'm doing it to this entire side, not just to this fraction, notice I'm multiplying this entire side. It happens to be just one fraction, but I'm multiplying this entire side by 4, so I have to multiply this side by 4. Let me rewrite that the same way I wrote it over here. So I can now eliminate my 4 from the denominator. I'm left with a negative x equals negative 32. I can get rid of my negative sign by again multiplying by a negative 1, multiply this by negative 1, and I'm left with, I write it over here, x is equal to 32.